Okay, I'm having to do a voiceover here. I had recorded about 30 minutes worth of audio and video, and the audio wasn't working. So we'll try to catch up, and hopefully it won't seem too out of sync. We're going to go ahead and try to open up our quad indices now, and I'm going to use the 1 to 24,000 index. You'll see there's also a 1 to 100 and a 1 to 250,000 in there, and there are two of the 250s. You can use either one of those. The SDC is a compressed format that's proprietary to ESRI. So we'll use the SDC, and we'll use the 1 to 24,000 quads in this example. The other ones are useful if you want to cover a larger area with having to only download one or two files. As you can see in this case, there are many of the 24,000 scales, and here you're seeing it zoomed out. I'll clear it first so you can see the state boundary through there. So you can see these are for New Mexico, but if you want to zoom out and see the entire country, that'll give you a better perspective of just how many there are. So first let's look at it here with New Mexico sort of defined, and then let's zoom out to the extent of all of the topo quads. We'll zoom to layer, and you can see for the contiguous 48 we have all of those here in that layer. And if we go out and open the attribute table for that, you can see that there are nearly 54,000 quads in this data file, and so it's an enormous number of quads to cover at the 1 to 24,000 scale of resolution, or 7.5 minute. You often hear of them that way as well. To cover all of the US, it's a lot of files. Of course, we're only interested in the ones here for the Gila Wilderness in this example. And what I could do, I could go through this table, and I'm pointing out here, by the way, that this is the ID number that the USGS has given each of these quads, and I believe it's the upper left corner Latin long coordinates. I believe is embedded in that name. Then you have, of course, the quad name, which is the more common name field, a state field, and notice there are three or four different state fields here, and that's because every now and then a quad will lie into more than one state. So it's they're covered that way. The primary state's always listed first, and there are a couple miscellaneous fields for date that was updated and so forth. Now we could go out and what we really are interested in is the quads that cover the Gila Wilderness, and you could go in here and look at those and try to individually select them. If you did that, you'd have to be very careful to get ones that go into a different quad, into a corner of another quad, like the one I just clicked on. Shows you just a piece of that is in that quad, but you'd still need all of that quad to cover that. There's a piece of the Gila in that quad. So you would need that. And here I'm trying to set it up to where we can select just a given quad to be able to see what we have there. And I was having a little bit of difficulty getting my selections to work. And you could also go in and select that like you did in the book with using the selection tools and using the select by location feature. Every time I kept clicking on it, I kept popping up with the state, and that's because I was actually not selecting. I was doing the information. It was picking the top layer, so the top layer was the state. And so when I went in and set that to topo quad here, then it gave me just the quad name. So I can see that Black Mountain is the name of that quad that has just a little piece of the Gila in it. And you can use the selection tool, it turns out, to go through and just select one. And just make sure that you have it set properly up here, and it will define the quad, which is kind of a nice new feature of ArcGIS-10. It gives you the name of the that's set in the properties, basically the layer feature name there, and so you can click on each one and see the name. So you could go through and do this one by one, which can be pretty tedious, or you can try to just select them in bulk. And again, you could use the selection tool to do that and select by location, or you can draw a polygon around this to select those. And so here in just a minute I'll be drawing a polygon around it so we can select all of them in one batch. And you can visually see it's pretty obvious here in this case that if you get this rectangle, you can do a rectangle around these and capture all of them. So I'll set my select tool and go in and draw that rectangle around those quads that have part of the boundary in it, and that selects all of those. And I can zoom to that extent and see just the quads that are in my layer. I can go in here, then once they're selected, change the selected feature over to show only selected, and I can see that there are 28 quads out of that nearly 54,000 total that covered the Gila Wilderness. All of them are in New Mexico. And since I'm interested in just those quads that cover the Gila, one thing I might want to do is go out and create like we did earlier with the wilderness areas. While it's selected, I can go in and easily export just those quads into a new file, and I can end up with a file that shows just the quads for the Gila Wilderness area, which is kind of nice to have. So we'll go ahead and do that since we have it selected here. And since this is a voiceover, I can't remember exactly what I was saying the first go round, so we're waiting for me to finish with whatever I was doing before. And I think I was just emphasizing again what I've already said, that it is you want to be careful to select everything that actually touches your boundary. So we can go in and before we do the export, I guess what I was doing here is I was setting the name, setting the label name to quad name so that you could see what the names were for each of those quads visually, which is kind of nice. And that shows you the quad names. So these are the names that you would want to be searching for when you're trying to download data at this level of resolution. And so a lot of times data is organized in a list when you go to a site by the name of the quad. Sometimes it's just that number, which might match that ID number we saw earlier. But it's pretty common to see them organized by quad name, especially when you're getting things like DRG data and DEM data and things like that. But again, here we have still the whole file. We've got a large file here with a lot of data in it, and we're really now only interested in just the quads that cover the Gila Wilderness area. So we want to go in and go to data and export the data, and the selected features is already set by default. We want to save it in the same source data, projection, and so forth that it's in currently. But notice that it was by default routing it to a different folder. We want to save that into our working folder, which is remembered here when I go to this drop box as the mark and the vector folder. So we'll just go in here and we'll change the name and we'll call it something like Gila Quads. And we'll save that, say OK, and ask if we want to add it to our map, say yes, and there you can see by the different color that we have a new layer that's come in there. But let's just go ahead and turn off the other layers that we don't need any longer, the overall topo quad index, and we can set our new one to clear so you can see those, and we can go ahead and get rid of the old one since we don't need it any longer. And while we're at it, we can go in and get rid of the old wilderness that shows all of the wilderness areas because we have our Gila separated. And we can go in and let's keep the federal lands layer because we later might want to isolate like the Gila National Forest, which surrounds and encompasses the Gila area. So we'll save that for later. But let's keep it in our list for now. And if we go in and we can label our quads and just turn label features on, since we know from before that quad name was set by default as the ID field for the labels. And there you have a map just of the quad indexes for our area. And it's nice if you can get this out into something that you can print it out, have it with you outside of the program, and you can also export this to a file. We'll export it, and I'll show you a way to export it that's pretty neat in terms of some of the advantages you can have. So we're going to export it. We could export it as JPEG or any of the other variety of formats, but let's pick PDF. and we'll route it over to our working folder. And we want to make a new folder in this case. Instead of having it in data or projects, let's make a folder called maps. And we can use this to store any kind of maps that we want to export, or anything we might want to put in there that we've scanned or something like that. And let's give it the name. Let's call it Gila Quads. And we can put a space in there this time because it's just an image. It's not something we're using in the GIS itself. Let's make sure the resolution is set to 300. And I'm going to check some of the tabs and get over to the advanced here in a minute. And I just wanted to make sure that everything was set up okay in there. And these defaults that came with it are pretty good, looks like. You'll see that it's set to export PDF layers only. We could export also attribute data with that if we wanted to. But that can make your file size quite large, and it can be a little confusing to people because they're not using the GIS per se. So let's just keep it to the PDF layers only. And we'll go ahead and save that. It saved pretty quickly here in this example. The first time you save, it might take it a few minutes. And it created a PDF file for us in the Maps folder. So let's go in there and open that up. And you'll see that there's only one file. Let's open that. And I have to move it over to my screen. Open on my other window. We'll move it over. And when everything gets set, we'll maximize that window. And there you have it. There's a PDF file. It's a small file. And there's a nice feature with Adobe Reader that's included as part of the Adobe Reader now that a lot of people don't know about. And that is the layers feature. And when you export out of ArcGIS the way I did earlier, it will save your data actually in layers just like you have it in the GIS. And in this Adobe Reader, you can turn these layers on and off, which is kind of neat, just like it was in the GIS. Yet somebody could do this that didn't know the first thing about GIS. So it's kind of nice. If you had a pretty sophisticated map with lots of information on it, it makes it pretty flexible because people can set it to show only what they want to show, print it out or whatever they want there, make a hard copy, and so you give them some of the features that you have in a map viewing or GIS program, all built into Adobe Reader. And you don't have to do a lot of special things for it. And a lot of times the file size is actually smaller than an image file, a true image like a JPEG, for example, would be. Though I use JPEG a lot and I export things as JPEG a lot, it is handy sometimes to export the PDF though this way. And here we have now, so we end up with a map that we can print out again and use as a reference when we're downloading data later on. So we'll close that. We're back in ArcMap, and now we're looking our area over a little bit here. And it looks like when I drew my polygon, I got one quad there that's not in the wilderness area, as you can tell, which is another reason that you might want to use the selection and select by location to do this, because that will get you the true quads that actually intersect the boundary of that, just like you did in the book. I did it here, kind of makes it nice and neat rectangle, but again, it's going to cause us to download at least one or two, I can see, two, maybe even three quads that we really don't need. So if I went to and did it by select by location, I'd want to make sure that the Gila boundary was selected first, then use that as my selecting layer and select from the topo indices or quads using that selected Gila layer. And that will give us just the quads that intersect the area. And it might make a big difference if you've got a large area, like say Yellowstone, for example. You know, you're going to have hundreds of quads that cover that area, or at least 100. And you're not going to want to download all of those, by the way. In that case, you'll probably want to use a larger scale and get an initial image of the area and then download selectively where you're going to do your analysis or something like that at this level of resolution. it can take quite a while to do that, and there's a lot of workload that can be shared when doing all of this, and I think that's what I'm pointing out here the first go round. I was trying to mention that you need to plan how you download your data strategically within your group, and make sure that that you're not repeating each other's efforts when it comes to getting your base data. And all of that base data can be put in a folder structure that is shared with everybody. The important thing is to make sure that you have the same folder structure on each other's computer, and everybody will have a base data folder to start with, and then each member will have their own data folder within that project folder. Okay, and then from that point, you don't have to share all of your data at the beginning, at least, that's in your own personal project folder. You'll want to definitely share the base data folder data though. And at the end, everybody will pool all their data together. The project leader will collect all of that data. Now I'm going to go in here. I guess I'm saving the project, looks like. And an advantage if you save your data the way I'm suggesting, i.e. that everybody has it all in the same subfolder structure, then when you save an MXD file, you can share that MXD file back and forth, and it will actually open correctly on each of your team members' computers, because everybody will have the data that goes with that MXD file, and it will already be in the same folder structure. That's the real key, that it's in the same folder structure. Otherwise, you'll get the red exclamation marks popping up everywhere for your layers that it can't find the layer. So make sure your folder structures are the same, whichever method you use. And then when you save your MXD files, again, they're relatively small. You can even email those back and forth real easily. So if you make a neat project you want to share with the rest of your team, then just make an MXD file and send that to them in the email, and instruct them to put it in the same location you had it in, which will hopefully be either in a project subfolder or in your name in a project subfolder, something like that, somewhere that is intuitive. And then they can open it up on their end and everything should work. Now, if you want to share your data continuously as you are updating it, even with your own personal folders of your part of the project, that's fine too. You're going to end up sharing that at the end anyway. But if you want to share it as you go, that's fine. It can be a little tedious because you'll be downloading data on your own, and at that point you'll be engrossed in doing your analysis, and you might not be of the same mindset of sharing it with everybody or be ready to share it with everybody yet. Just make sure that everybody does have the same base data, and that you either divvy up the workload on downloading that, or if somebody downloads it, then share it with the others or so forth. And you might use tools I've suggested elsewhere like Dropbox, things like that for helping with your data sharing. And in the worst case is a good old-fashioned snail mail. You can make a CD and burn it CD and send it to each other in the mail. But I would encourage you to try to be creative. Give that Dropbox a try. I think it works really well, and you can share data easily with that. So, and you'll notice I've got the same subfolder structure under the Mark folder here that we had under the base data folder once we got into that. And again, this is just another way of doing it. I've given you one example out there that you have to download the sample folder structure. That's in a lot of detail. You can also do something like this. It's not quite as much detail and still pretty intuitive. You've got your obvious vector data, raster data, your archives, and then I had a little catch-all for the other. That's up to you. I'm going to save this now, and let's save it and make sure we route it to, again, our working folder in the project subfolder. Okay, so we want to pick the GIS-110, go into our project folder under Gila. I have a project subfolder already set up, and I have a Gila 1 in here where I was entering and doing some practice earlier. And just in case that's important, I'm going to go ahead and call this Gila 2 for now. You might call it Gila Mark, or I could call it any variety of names, and I could store it. I've got it in my projects folder here. Well, you might have in your case a projects folder in each of your team members' names as well, and they can store their individual projects there, whatever works most conveniently for you. But just make sure that you save it periodically so you don't lose your work, as that's happened to me quite a bit, and it's pretty frustrating. So there we have this project. I could have also just called this location, because really that was the idea here, was to help you get down to your location of your study area. So just to summarize, we have taken a variety of data sets that we downloaded, and I showed you places where I downloaded the files. I will save these files for you, at least the ones that I used to derive my Gila files from, and I'll zip those up and put them on our data sources folder, and I'll try to do that right away. But that we took that data, took information from our larger region and narrowed it down to the area we were interested in. I showed you how to the equivalent of clip out your area by basically selecting it and then exporting just what you had selected. That gave us a new layer for the Gila boundary in one case. We also did that with the quad indexes that were in the vicinity of our area. We got a few that were actually outside the area in that process, because we did it by using the rectangle to select a box around it. You can do it that way, but you may end up getting some data you don't necessarily need, but that's one option. Or you could go in and select by location and use your boundary to select those quads that you actually need out of there. And so you saw how to do that. Hopefully this gives you enough information to get started with. And there's a variety of things you can do here to get to this point. You can split the workload up as you wish. It's basically just a starting point to get you narrowed down to your area, let you know where that is geographically, spatially, and to let you get a list of 1 to 24,000 topo quads that you'll need. And when you go to download things like DRG data, DEM data, and things like that, a lot of times you'll find it listed by quad name, and 9 times out of 10 it will be the 1 to 24,000 quads. And so this can be very helpful to you when you get to that point. So I hope this helped. It's an hour and a half long or so to show you something relatively simple, but along the way I tried to cover some details that I hope were helpful to you in the naming structure and the folding structure, and showing you some data sources and things like that. And we'll do this again. I'll try to create some more videos that shows some more stages of the process, but again, this should get you started, and just keep me posted on how things are going. If you have any problems with this, let me know. As far as I know, the only layer you'll have to define a projection for is the federal lands layer, and if I zip up my data here that I've done, you won't even have to do that. So check it first with ArcCatalog just for fun to make sure, but I'm pretty sure you won't even have to define that layer. So, but I did want you to make sure that you knew how to define a layer, so we actually went through that process in this video as well. So good luck, enjoy it, and we'll be back soon.